that's all about the chapter. Now let's recapitulate the chapter. What are the topics that we have discussed in this chapter? So first of all, we have understood the concept of motion. Now what is motion basically? Motion of an object is when the object changes its position with respect to time. That is, by changing the time, like with going on of the time, the object changes its position from one place to another. Then only we are going to say that the object was in motion, right? After that, we have discussed about the different types of motion. That is, what are the different types of motion? Rectilinear motion. Here, when the object is moving in a straight line, then we'll say that the object is doing the rectilinear motion. After that, we have studied about or understood about the concept of periodic motion, where the object repeats its motion after certain period of time or equal interval of time. Then we have understood about the rectilinear motion, rotational motion, how the motion was described as slow and fast based on the speed, and again when equal interval of time and distance are seen, then we can say that the object was in uniform motion. Otherwise, if there is unequal interval of time and distance, in that case we'll say that the object was in non-uniform motion. So that is how we have understood the concept of different types of motion. After that, we have moved to the other topic, that is speed. Now what is speed basically? That is how much distance traveled by an object in certain time, and that we have understood by a formula, that is distance upon time. Here again the units of speed for that becomes kilometer per hour, meter per second, based on the units of distance and time given. So that is how the speed is calculated. Now here it is a small trick for you to represent the to learn the formulas or just remember the formulas of distance, speed and time. Now here you can see that I have made a triangle where distance, speed and time are mentioned, and from that triangle different formulas are made. Like in first case, that is if we need to find the speed, there the speed, as we know that it is distance upon time. In second case, distance becomes speed into time, and in third case it becomes where we need to find the time, that is distance upon speed. Now how you are going to remember this formula is just make this triangle, small triangle, and divide the triangle. In upper portion write D, which represent distance. In down portion, divide this down portion into two parts, speed and time. Now here see carefully. Now if you need to find the speed, that is this one, this first case. Now here cover this and see how distance and time are there, that is they are in divide form. So write the formula here. So that is speed becomes d by t. Now in second case, where what you need to do is just you need to find the distance. Now here in the second case, now cover this. Now see, when distance is covered or when you are finding distance, what are the two things left is speed and time. As they are side by side, what we are going to do is we are just simply going to multiply them. And in the third case, where you need to find the time, again cover this or shade this portion, and what are the other two units left, that is D and S, and how they are present here, that is in the divide form, like one is in the numerator, other is in the denominator. Write that formula, that is D by S, and that is how you can easily remember these three formulas to calculate distance, speed and time, right? After that, we have seen that how we measure the time, that is by certain devices like clock, watches, sundials, sand clocks, water clocks, pendulums. Like that we have understood the different concepts. So after that we have understood the concept of oscillation. Now how one oscillation is described, when the object, or we can say that when the bob of the pendulum moves from its mean position to extreme position, and then from there to another extreme position and come back to mean position. That is how one oscillation is considered. And this type of motion where the object moves from moves in to and fro motion, that type of motion is known as oscillatory motion, and this is basically seen in the case of pendulum, or you can say that a motion of a child on a swing, or we can say that another example for that is motion of a needle of a sewing machine. So all that shows the oscillatory motion, that is to and fro motion, or we can say that back and forth motion. So that is how we describe the oscillatory motion, and we already understood this concept in our chapter. After that, at last, we have moved on our topic, that is distance time graphs, which are very important graphs. Here what we have understood, like if some data is given, like how much distance is covered by the object in certain time, how we are going to represent that in the distance in the graph form, that we have understood. Now, if there is equal interval in between distance and time, then the graph represents the uniform motion, and if there is unequal intervals between distance and time, then the graph has represented the non-uniform motion. And from distance and time graph, what is the main thing which we understood, or which for which we get the data, is our speed. That is the line what we got after joining the points, that is basically represents the speed. If the line is more slant, that shows the object has covered more distance in less time, that is the object is moving with a fast speed. But if that line, the slope is less slant, that will show that the object is covering more distance in less time. So that is how we define or we understand the distance time graph. So these are the topics which we have already understood in this chapter. Thank you.